Hello everyone, thank you for signing in and watching my live session. This is Geometry, I'm Mr. Matt, this is Dr. Tot. And last session we began our discussion about patterns and using inductive reasoning to decipher patterns and make suggestions or predictions about the subsequent terms in a particular pattern. Before we got into the nuts and bolts of actually looking at sequences or a few sequences, we talked about a few conceptual terms that I just want to highlight. And in doing so, let me start by sharing my screen with you. Okay. So first, to introduce inductive versus deductive reasoning, we started to talk about a few conceptual terms. The first was a comparison between qualitative and quantitative values. Oop. So when we say qualitative, qualitative goes to description. It takes the form of either usually adjectives or adverbs to describe how, or in sometimes why, but usually how something, or how fast, how colorful, how strong something is. So for example, we might say like this car is fast, and that car is definitely faster than the first car, and this third car is the fastest of them all. But it's all relative and it's all descriptive. Okay, so qualitative information has to go to descriptive or words, using words to describe the scenario. Quantitative information involves the introduction of numeric values. So there you can have exactitude. So maybe this car is going 38 miles an hour, this second car is going 39 miles an hour, but this third car is going 60 miles an hour. So now it's not just an ordination of fast, faster, and fastest. You have explicit values to quantify the speed and the speed differences between the cars. So it's a much more powerful and exact type of tool. Sometimes in analysis, you're limited to a certain type of information. For example, like patient satisfaction or customer satisfaction. You could use quantitative information to rate customer satisfaction on like a 1 to 10 scale, but it's still somewhat subjective. But usually it's like, were you satisfied? Are you not satisfied? Did they do a poor job, an excellent job, a good job, an average job? Those are all descriptors that would go into making up a qualitative analysis of a particular job performance. Then we talked about, along the same lines, or kind of like a parallel to that, you can think of it as, but subjective versus objective information. So subjective information is information that is determined by a person's individual interpretation or perception. So beauty, kind of like the phrase, beauty is in the eye of the beholder. What you think is beautiful, concise, or invigorating language may not be so interesting to another individual, just based on taste differences in tastes and preferences. So subjectivity involves personal interpretation, whereas objectivity should be or reaches towards a point of universal knowledge or truth. So a lot of time, like for instance, math is a very objective study. X is either 2 or X is not 2. There's no question at the end of the problem. X is what X is, or the unknown turns out to be the value that it is calculated to be. So subjective versus objective information. Not exactly the same thing as qualitative versus quantitative, but you can see that they have commonalities with each other, at least conceptually. And so this leads us up to what we're talking about today, inductive versus deductive reasoning. So inductive reasoning is the use of observations or patterns to establish a rule. Deductive reasoning is using a rule to establish a conclusion about something based on what that rule says it should be. So inductive reasoning says, well, every gumball that comes out of the gumball machine is in this pattern. It's red, blue, red, blue, red, blue. So observing the pattern from a bottom-up approach, we're constructing a rule. A slot machine, however, that has a program in it that says, and I'm not saying this is how slot machines actually work, but let's just say this hypothetical slot machine, every 100th turn, you win a jackpot. That's a program, that's a rule that is commanding the outcome of a particular turn or bet on the slot machine. So that is the difference between inductive versus deductive. So you can see how we're using open to perception, using a pattern, or using our observation to establish a pattern is the process of deductive reasoning. Taking a pattern and applying it to a situation, top-down reasoning, is deductive reasoning. So what we're going to be looking at today is mainly inductive reasoning by establishing rules based on particular patterns. So what I'd like to start with is some some qualitative data. So notice that these are all descriptive words. They're all nouns. I think they're all nouns. Yep, they look like all nouns to me. But you're going to have to understand, try to categorize how these nouns relate to each other. What relationship do they have? What categories can you place the items in? And therefore, how can you decipher one from another? And can you come up with a rule to predict the next 3 items? Okay, so I'm going to give you 5 minutes. Please look at these 4 problems. Okay, so if we look at the first sequence, we have rose, mouse, oak tree, goat, dandelion, cow, lily. So notice that rose, if we try and put these into categories relative to each other, rose is a kind of plant, specifically a flower, but generally a plant. A mouse is an animal. An oak tree is a type of plant. A goat is a type of animal. A dandelion is a type of plant. A cow is a type of animal. A lily is a type of plant. So you can see that we've established a pattern here, and we can create a rule that this sequence goes in an order of plant, animal, repeating. So the next three terms, we could just make some suggestions here. So it could be, we ended with a plant, so it could be any animal. So maybe we could say dog. We need another plant, so maybe cactus. And then another dog, maybe snake. If there's any questions, let me know. For the second example here, let me just put this aside. Get another copy here. So for the second example, we have tires, steering wheel, refrigerator, seatbelt, door handle, oven. So a tire is something that's found on a car. So is a steering wheel. So we have some type of car part. I should put part. Car part, car part. A refrigerator is found in a kitchen. Seatbelt is a car part. Door handle, we can assume in this context, is also part of a car. Oven is found in a kitchen. So we need two more car parts and then something that's found in the kitchen. So maybe we could have like a sun visor, comma, radio, comma, stove, because a stove is found in a kitchen. Okay, but it could be anything that follows that general rule. The third example here, we have cell phone, calculator, paper airplane, television, flashlight, brick. So really you could see that this is electronic versus non-electronic. Right, so you have an electronic device, non-electronic device, electronic, electronic, non-electronic. So we need two more electronic devices and then a non-electronic device, or maybe an iPhone. Maybe we can do a speaker. And then a non-electronic device, keys. Well, keys sometimes are electronic, aren't they, nowadays? Let's say a necklace. Let's assume it's non-electronic. I know sometimes necklaces can be electronic. I think everything can be electronic nowadays, so that pattern might be hopeless. Now let's look at the last one here. So we have staircase, tree, fireplace, hill, door, river, table, rainbow. Let me just move this down here so I can write underneath of it. So staircase versus a tree versus a fireplace versus a hill versus a door versus a river versus a table versus a rainbow. You might be able to see that this is a pattern. Move these guys down here. This is a pattern of something that's found inside versus something that's found outside. Fireplace is inside, a hill is outside, a door is inside, a river is outside, A table is inside. A rainbow can be found outside, generally. So we need something that's found inside, maybe a desk. Something that's found outside, maybe a cliff. And then something that's found inside again, maybe a lamp. Okay, so we're trying to categorize these descriptive words into groups that make sense because they contrast with each other. We're trying to find similarities between some items, contrast that with differences between other items, create a general rule in the sequence in order to predict the next items that come in the series. If you have any questions, please let me know. Otherwise, let's look at this next list. I'll give you 4 minutes. Okay, so let's look at these guys. So the first one, we have David, Felicia, Alex, Monica, Robert, Patricia. So these are in a form of what's typically thought of as a conventional male name, followed by a conventionally thought of as female name, and then the pattern is repeated. So maybe the next three items we end on a female's name. So let's so we need to alternate to a male's name. Let's say we already used David. Let's say Brian, Carla, and let's say Derek. Second one, Michael, Roger, Rachel, Doug, Ricardo, Sheila. So now we have male, male, female, male, male, female. So we need two more males. Let's say Richard. Let's say Dave. And let's say Irene. Third example, Alexis, Maria, Marcus, Shirley, Carol, Dave, Lucia. So now we have female, female, male, female, female, male, female, then we need a female, male, female. So we could maybe say Jessica, Louis, and then maybe Mary. And last one, a little bit different, hamburger, fried rice, orange juice, Pepsi, tater tots, green bean casserole. So we have food, food, beverage, beverage, food, food. So beverage, let's say coffee, tea, and cookies. Okay, if you have any questions on that, please let me know. Let's do one more example. I'm going to give you 2 minutes this time, really speed it up. So the first example here, we have magazine, wrench, newspaper, engine, tissue box, muffin tin. So to me, the pattern looks like made of paper, made of metal, made of paper, made of metal, made of paper, made of metal. So we need something made of paper. Let's say a phone book. Something made of metal, let's say a nail. Something made of paper again, let's say a user manual. Second example, Sprite, gasoline, spoon, grape juice, bleach, rock. So to me it looks like solid versus liquid. Sprite is a liquid, gasoline is a liquid, a spoon is a solid, grape juice is a liquid, bleach is a liquid, rock is a solid. So now we need two liquids and a solid. So maybe we can say orange juice. Let's say Dr. Pepper. And then something solid. Let's say a boulder. Third example, paintbrush, poster, highlighter, sticky note, marker, thank you note. So to me, this pattern looks like something you write on, something you write with, and then something you write on. So you write with, or you paint with a paintbrush, you write on a poster, you highlight with a highlighter, you write on a sticky note, you mark with a marker, you write on a thank you note. So maybe we could have a pencil. We could write with a pencil. We could write that on lined paper. And another writing implement, we could use a pen. So maybe pencil, lined paper, pen, or some combination there. Last one, we have dolphin, piranha, giraffe, whale, shrimp, bison. So to me, this looks like an animal that lives in the water, followed by an animal that lives in the water, followed by an animal that lives on land, and then repeating. So we have water, water, land, water, water, land. So we need two more waters than a land animal. So we could say maybe a shark, a jellyfish, and a horse. If you have any questions, please let me know. Otherwise, I'm going to skip over that for now. I just want to make sure that we have enough time to get into the quantitative data. So now I would like you to look at the following sets of numbers and try and establish a sequence. So now you're not going to be looking for, in order to try and put them into categories, you're going to want to compare sequential terms and to see what the difference between the terms is. Now you could either look at it that there is a constant value that is being either added or subtracted sequentially from the values, or the values could be in a specific ratio, meaning that they're changing by a scalar factor rather than a finite factor. So a finite factor is adding or subtracting a set amount, like if I just subtract away 10 from 20, or versus if I take away 10 from 1,000. Those are two very different numbers, but they don't have any relationship with each other, nor do they have any relationship specifically with 10 other than their numbers. But if I each time am doubling, then I have a scalar relationship. I have a projection over one common multiple, so all of the multiples have this relationship with each other. So that's the difference between having a finite change versus a scalar change. To test these, to test whether something has a scalar or finite change, if you subtract sequential values and it turns out to be a constant value is being added or subtracted, then that's a finite summation or a finite subtraction sequentially. However, if the sequential terms are in some type of ratio with one another, then subtracting the values won't do any good. That won't yield a constant value. However, if you take one value, if you take the next value and divide it by the first value or the previous value, let me rephrase that. If you take any value and divide it by the previous term, then if you compare that ratio, if it's constant, that means that there's a scalar multiple that's being applied, either increasingly or either with increasing effects or decreasing effects. whether you're multiplying by a number greater than 1 or in between 0 and 1 will determine that. But there is a difference here. If you're having a finite, if you just are adding a constant value or subtracting a constant value each term, then you have a finite addition and subtraction. And if you look at the difference between terms, that will be the same difference between each successive term in the sequence. If you divide the values and find that there's a constant ratio that all of the terms are in, then that's indicative of it being a scalar relationship. And so maybe each subsequent term is 3 times the previous term. That's obviously going to grow very, very large very quickly, but you would check that by taking the second term and dividing it by the first, comparing that ratio to the third term divided by the second, comparing that ratio by the fourth term divided by the third. If there's a scalar relationship, then those ratios, those values, the quotients, the answer to the division problem that you do will all be the same. Okay, so I'll give you 4 minutes. Please look at these 4 problems, and then we will talk about them. Oops. Okay, so if we look at this first pattern, if you take 30 minus 25, the difference here is 5, plus 5. 35 minus 30 is another plus 5 difference. 40 minus 35 is another plus 5 difference. 45 minus 40, again, plus 5 in difference. So we can generalize a rule here that each term in the sequence is 5 units greater than the previous term. So the next term would be 45 plus 5, which would be 50. 50 plus 5 would be the second term, missing term would be 55. Then 55 plus 5 would be 60. Conversely, if you look at the second example here, 24 minus 30, that's a minus 6 change. 18 minus 24, that's a minus 6 change. 12 minus 18 is a minus 6 change. 6 minus 12 is also minus 6. So now we can just say that the rule is subtract 6. 6 minus 6 is 0. 0 minus 6 is negative 6. Negative 6 minus 6 is going to be negative 12. Looking at the third example, 180 minus 20 is a minus 20 change. 160 minus 180 is another minus 20 change. 140 minus 160 is a negative 20 change. And 120 minus 140 is also a negative 20 change. So subtracting 20 as we continue, 120 minus 20 is going to be 100. 100 minus 20 will be 80. 80 minus 20 would be 60. Last example, 45 minus 30 is a plus 15 change. 60 minus 45, also a plus 15. 75 minus 60, also plus 15. And 90 minus 75 is also a plus 15 change. So the rule here is going to be add 15. So 90 plus 15 is going to be 105. 105 plus 15 would be 120. 120 plus 15 would be 135. If you have any questions, please let me know. Otherwise, let's look at this problem set. I'm going to give you 2 minutes just looking at the time and make sure that we get through everything by session's end. But I'll give you 2 minutes and then I'll give you the answers. Okay, let's look at these next problems. If you heard any of those noises, I think Dr. Top fell asleep, so he was daydreaming, or actually dreaming. Now, if you tried to find the difference between successive terms here, excuse me, you might have come up, you might have found yourself in a little bit of trouble, because 4 minus 2, that's a plus 2 change, but 8 minus 4, that's a plus 4 change. And 16 minus 8, that's going to be a plus 8 change. So notice that the values, the differences here are not constant. So that's indicative of a scalar relationship. So instead of subtracting, you want to divide. 4 divided by 2 is times 2. To go from 2 to 4, you have to times by 2. 8 divided by 4 is also 2, meaning to go from 4 to 8, you have to multiply by 2. 16 divided by 8 is 2, meaning to go from 8 to 16 is also a times 2 change. So the rule here is just times 2. 16 times 2 is going to be 32. 32 times 2 is 64. 64 times 2 will be 128. Looking at that rule and establishing the next pattern, 15 divided by 5 is going to be a times 3 change. 45 divided by 15 is also going to indicate a times 3. To go from 15 to 45, you have to multiply by 3. To go from 45 to 135, again, if you divide, do the opposite, that'll give you that answer. 135 divided by 45 is 3. So 45 times 3 is 135. So if we do 135 times 3, we get 405. 405 times 3 would be 1,215. 1,215 times 3 is going to be 3,645. For number 3, 12 divided by 4 is a times 3 factor. 36 divided by 12 is a times 3 factor. 108 divided by 36 is also a times 3 factor. So the rule here is going to also multiply by 3. 108 times 3 is going to be 324. 324 times 3 is going to be 972. 972 times 3 is going to be 2,916. And last but not least, if we look at the change here, 50 divided by 10 is a times 5 change. 250 divided by 50 is a times 5. 1,250 divided by 250 is also a times 5. It's a scalar increase of times 5. So 1,250 times 5 would be 6,250. 6,250 times 5 is going to be 31,250. 31,250 times 5 is going to be 156,250. If there are any questions on anything that we've done today, then please let me know. If you haven't already, please like, favorite, and subscribe to my channel and videos. Every Wednesday, excuse me, trying to increase my camera here. It's not wanting to cooperate. There you go. So remember that every Monday, Wednesday, and Friday are the math sessions. Tuesdays are reading sessions, and Thursdays are writing sessions. Each day the math classes are formatted from SAT prep to pre-algebra to geometry to algebra 1 to algebra 2. The reading and writing classes are clustered in grade groups, so we have grades 9, 10. Well, first we start off with the SAT course, then we have grades 9 and 10, then clusters 11 and 12, then the AP language group, and then the AP literature group. I'm going to continue to post all the links to all of these YouTube live sessions on my Facebook page that I'll include a link in the description. Please share with any friends and family, and thank you guys very much for signing in. I hope you have a wonderful night, and I will talk to you all on